maxima and minima. When a function is said to have a maximum value and minimum value, let f of x is a function defined in an interval I. It is a function in interval I. Then f of x is said to have maximum value. F of x is having maximum value. Maximum value at c, at the point x equal to c, when f of c is greater than f of x for every x in the interval I. So what is maximum? F of x is maximum at c when f of c is greater than f of x for all x element of I. Similarly, f of x is having minimum. Is minimum when f of c is less than f of x for every x element of I. Maximum when it is the greatest among all the values. That's all. Minimum when it is the least among all the values in that interval. Whether it maximum or minimum, it is called extreme value. So let us do one problem. Find maximum and minimum value. Maximum and minimum value, if any, for the function f of x equal to x squared, x element of R. What is asked? Find maximum and minimum if it exists for the function f of x equal to x squared. We already know what is the graph of f of x equal to x squared. What is it? This is the graph of f of x equal to x squared. Look at this graph. It has any maximum? No, it is going on. It has any minimum? Yes, this is the minimum point. Below that there is no other point. So from the graph itself we can understand f of x has minimum at this point. At this point means at x equal to 0 minimum exists. And what is the minimum value of the function? Value of the function is f of x or y. What is the minimum value? It is also 0 because y is 0. So minimum x is at x equal to 0 and minimum value is 0. And what about maximum value? We will write maximum does not exist because it is going on, does not exist. Let us do another problem. Find maximum and minimum value if it exists for the function f of x equal to modulus x plus 3. And what is the graph of modulus x plus 3? Modulus x means it passes through origin, V-shaped graph. So modulus x plus 3 raised to 3 points. So this is modulus x plus 3. Now look at this graph. Does it have any maximum? No, it is going on. So we can write maximum does not exist. Any minimum value? Yes, this is the minimum value. Below that there is no other point for the graph. So this is minimum. So minimum value at which point? Minimum value at which point? At x equal to 0. This point is x equal to 0. And what is the minimum value? The function value is f of x or it is y. So minimum value exists at x equal to 0 and what is the minimum value? Minimum value is f of 0 and it is equal to 3. Minimum value at x is at the point x and the minimum value is the value of the function or f of x or it is y. So it is written as 3. Next question, find maximum and minimum if any for function f of x equal to x where x is element of open interval 0, 1. So how will be the graph? F of x equal to x means the identity function. Identity function graph we know. It bisects the first quadrant and third quadrant. But here interval is given as what? 0 to 1. X equal to 0 is origin and x equal to 1. Let us mark this point. 1. So what is the graph? 0, 0 is a point, but a 0 is in open interval. So we have to exclude 0, 0. 1, 1 is another point. That point also we have to exclude because it is open interval. So the graph of f of x equal to x is this with the two ends open because it is open interval 0, 1. Now this graph has any maximum or minimum. Let us check. What is maximum value? The value near to 1. But what is the nearest point to 1? We cannot estimate what is the nearest point. Whatever point you take, there is the next point. So we cannot estimate the nearest point at x equal to 1. Similarly, the minimum point is at 0. This point also we cannot correctly tell which is the minimum value. So what answer we should write? Find the maximum minimum for f of x equal to x element of 0, 1. No maxima and minima exist. Neither maxima nor minima exist. Why? Because the value very near to 1 we cannot tell which is that value. Similarly, the minimum is the value very near to 0 which we cannot tell which is the point. If we make a slight modification in this problem such as f of x equal to x element of closed interval 0, 1, what will happen? Closed interval 0. Then these points will not be open like this. So this point will be included, isn't it? In that case, what is maxima and minima? So what is the maximum value? Here the maximum value is at x equal to 1 because that value is there in the function. So we can tell the maximum value is at x equal to 1 and maximum value is what? Is f of 1. What is f of 1? It is 1, the y value. Similarly, what is minimum? Minimum at x equal to 0 and minimum value is f of 0 and what is f of 0? It is equal to 0. So when the function is defined in closed interval 0, 1, minimum and maximum exists, but when it is defined in open interval 0, 1, minimum and maximum does not exist. Next is local maxima and local minima. Local means in that locality. When we take an interval, that is called the locality or the local. Let us illustrate with a graph. Let this be a function like that. Let the graph goes on. Let this be the graph of f of x. Now look at the graph. This value is a maximum value where not if we take the whole graph. If we take only this locality or even bigger you can take, no problem. Even in this locality this is maximum value. But if we take this locality, it is not local maximum. So when we consider an interval In that interval, it should be the maximum. That is why the term local maxima. The interval will be given. So consider this interval. This point is a local maxima. If we take this interval, what is the local maximum value? This is the local maximum. So at this point, whatever be the x, c, at this point the local maximum exists. Similarly, at another point x equal to any other point k you take, there also local maximum exists. And what is local minimum? Minimum means this value. This is a local minimum and this is another local minimum in different intervals. I hope you understood what is local maximum and local minimum. In that locality, it should be the maximum value. That's all. Now, look here, the local maximum point. If we concentrate on this point, let this be x equal to c. We consider a small interval c minus h and c plus h. In this interval, this is the local maximum. Look here. On the left of this maximum value, what happened to the graph? On the left means this part. What happened to the graph? The graph is increasing, or the value of f of x is increasing. On the right, value of f of x is decreasing. So here f of x is increasing and here f of x is decreasing. Is it true for all maximum values? Check here. This is another maximum. On the left it is increasing and on the right it is decreasing. So to get a maximum value, the left side should be increasing and the right side should be decreasing. So for maximum, what is the condition? Left side of f of c is increasing and right side is decreasing for maximum. For minimum, look here, this is minimum. For the minimum, what happened to the left side? Left side is decreasing and the right side is increasing. So for minimum, what is the condition? Left side is decreasing and right side is increasing. Okay, so that is the condition for local maxima and minima. And what is the value at this maxima? See, look here. This is a parallel line, or the slope is 0. So at this point the slope is 0, or we can say f dash c is 0, or f dash x is 0 at a maximum. And at minimum, what is it? Again, this is parallel. So f dash x is 0 at minimum and maximum. Both minimum and maximum, f dash x is 0. Then how will we discriminate maximum and minimum? For that we have to check the second condition. The left side of f of c is increasing or decreasing. If it is increasing and the right side is decreasing, it is maximum. If we check only one condition, left side is increasing. Look here, if we check at this value, it is going on increasing like this. This is not local maximum. So both conditions you should check. Left side should be increasing and right side should be decreasing for maximum. Now left side is increasing. How we will check it? Where we have learned for increasing functions, f dash x is greater than 0. And for decreasing function, f dash x is less than 0. So let us understand what are the conditions for maxima. What are the conditions? 3 conditions you have to check for maxima. What are the 3 conditions? So for local maxima, what are the 3 conditions to be checked? First you check, is f dash x equal to 0 at x equal to c? Then it is maxima or minima. Then we should take left of f of c. Left side of f of c. Consider the interval, that is interval c minus h, C in this interval. C minus H, C. In this interval, f of x should be increasing. F of x is increasing means f dash x greater than 0. This is the second condition. On the left side of f of c, f dash x should be greater than 0. And one more condition, right side of f of c is what means the interval c plus h. In this interval, f of x should be decreasing. When it is decreasing, f dash x should be less than 0. So these are the three conditions for local maxima. First is f dash x equal to 0. Left side f dash x increasing means f dash x greater than 0. Here f dash x equal to 0 and here f dash x less than 0. These three conditions we should check for local maxima. Similarly, for local minima, what should be the conditions? F dash x equal to 0. It is a condition. Then, on the left side, it is decreasing, means f dash x less than 0. On the right side, it is increasing, so f dash x greater than 0. For local minima, what are the changes we have to make? Local minima, what are the changes? First is same, f dash x equal to 0. On the left of f of c, means this part. What is it? It is decreasing. This part is changed. On the left side, it is decreasing, isn't it? For local minima, left side decreasing means f dash x should be less than 0. And on the right side, f dash x should be greater than 0. These are the conditions for local maxima and minima. This testing of maxima and minima is called first derivative test. So, what are the conditions of first derivative test? For local maxima, f dash x equal to 0, left side f dash x greater than 0 and right side f dash x less than 0. For local minima, f dash x equal to 0 and left side f dash x less than 0 and right side f dash x greater than 0. This is called first derivative test. By using this test, we can find local maxima and minima. Find all the points of local maxima and local minima of f of x equal to x cube minus 3x plus 3. So what is asked? You have to find all local maxima. There may be more than local maxima. See, look here, these two are maxima. That's why all points of local maxima and local minima is asked. So how to find? Whether it be maxima or minima, we know f dash x is 0. So first find what is f dash x. Derivative of x cube is 3x squared minus derivative of 3x is 3 and derivative of plus 3 is 0. So f dash x is 3x squared minus 3. For finding maxima or minima, equate it to 0. F dash x equal to 0 gives what? 3x squared minus 3 equal to 0. It implies what? 3x squared equal to 3, or we are getting x squared equal to 1. It implies what? X equal to plus or minus 1. So we got two values, two possibilities. X equal to plus 1 or minus 1. There maxima or minima. Some value exists there. That we got when we equate f dash x equal to 0. Now we have to find whether x equal to plus 1 is maxima or minima. So let us take the point. What is it? X equal to 1. Another point is x equal to negative 1. These are the 2 points. So to check the left side and right side, whether it is increasing or decreasing, we have to find. So on the left side, this is on the left side. On left side, which value we are going to consider? 1. In number line, the left side of 1 means we can take 0.9. On the right side, very close, you have to take, don't take big numbers, because the interval when it changes, the maximum may change. So on the right side, which value we are going to take? 1.1. So in this part, is it increasing or decreasing? How we will check? We have to find f dash of 0.9. If f dash of 0.9 is greater than 0, we get it is increasing here. If f dash of 0.9 is less than 0, we will get it is decreasing. Find f dash of 0.9. What is it? F dash x is this. So 3 into 0.9 squared minus 3. So 3 into 0.9 squared is what? 0.81 minus 3. Multiply. So it is 324. So 2.43 minus 3 means it is negative. F dash x is negative means here it is decreasing. Negative means decreasing. So on left side it is decreasing. Now on the right side let us check. What is f dash of 1.1? F dash of 1.1 is 3 into 1.1 squared minus 3. 3 into 1.1 is 1.21 minus 3. So it is 3.63 minus 3. So it is positive. When it is positive, here it is increasing. When it is positive, we are getting it is increasing on the right side. So what we got? On the left side, decreasing. At this point, on the left side, decreasing. And on the right side, it is increasing. So what is it? It is local minima. So we got x equal to 1 is local minima. Local minima. And what is minimum value? And minimum value is f of 1. Is f of 1. What is f of 1? We have to substitute it here. So 1 cube minus 3 into 1 plus 3. So 1 minus 3 plus 3. So it is 1. Minimum value is 1. So x equal to 1 is local minima and the minimum value is 1. Now we have to do this part. X equal to negative 1. Here also we will take the left side of negative 1 and right side of negative 1. Left side of negative 1 is what? In number line, if this is negative 1, what is left side? It is negative 1.1. And on the right side it is negative 0.9. So find the value f dash of negative 1.1. What is f dash of negative 1.1? In 3x squared minus 3, substitute x equal to negative 1.1. So 3 into negative 1.1 squared minus 3. Negative 1.1 squared is same as this one, 1.21. So we will get it as 3.63 minus 3, or it is positive 0.63. It is positive. So on left side positive means on left side f of x is increasing. On the left side f of x is increasing. Now check the right side. What is f dash of negative 0.9? It is 3 into negative 0.9 squared minus 3. So the same value calculate. When we get it is negative, because it is 2.43 minus 3 negative. So we got on the right side f of x is, f dash x is negative means f of x is decreasing. Look here. So on negative x equal to negative 1, left side is increasing. X equal to negative 1, this point. Left side is increasing and the right side is decreasing. Means it is what? It is local maxima. So local maxima at x equal to which value? X equal to negative 1, and maximum value is f of negative 1. f of negative 1. What is it? Negative 1 cube minus 3 into negative 1 plus 3. Negative 1 cube is negative 1 minus 3 into negative 1 plus 3 and plus 3. So 6 minus 1, 5. So local maximum value is 5. When we do problems to find local maxima and local minima by using first derivative test, just like the last question, it is so lengthy. So there is another method, second derivative test. When we use second derivative test, we can easily do the problem. So how to do, or what is second derivative test? So the conditions of second derivative test is for maximum, for f of x to be maximum. Maximum means local maximum. The first condition is same as the first derivative test. What is it? F dash x equal to 0. If it is at x equal to c, we can write, instead of x we can write f dash c should be 0. At x equal to c, local maximum for f dash c equal to 0. And the second condition is the second derivative. Second derivative should be negative, means it should be less than 0. So for local maximum, first derivative 0 and second derivative negative. For maximum, second derivative is negative. And for minimum, for local minimum, first condition same, f dash c is 0 and the second derivative positive, it should be greater than 0. So only this much we have to remember. For maximum to exist, first derivative 0 and second derivative negative for maximum, and for minimum, first derivative 0 and second derivative positive. Now look here, second derivative is less than 0, then what happens if the second derivative equal to 0? If f2 dash of c equal to 0, what will happen? The answer is second derivative test fails. So we cannot use second derivative test if a second derivative f2 dash of c equal to 0, then we can go back to first derivative test and complete the problem. Let us check the second derivative test with the last question we did. What was it? F of x equal to x cube minus 3x plus 3. And what conclusion we got? X equal to 1 is a local minima and x equal to negative 1 is local maxima. This was the result what we got on the last problem. Let us do the same problem with the second derivative test. So what is second derivative test? First find the derivative. First derivative f dash x equate to 0. So 3x squared minus 3 equated to 0. We got it as x equal to plus or minus 1. This is just like the last problem. Now the second derivative, let us find. What is f2 dash of x? f2 dash of x is 6x. 6x. Now what we have to do? Find f2 dash of plus 1. f2 dash of plus 1 is what? 6 into 1, or it is greater than 0. It is positive. It is greater than 0 means second derivative greater than 0 means what? X equal to 1 is local minima. The last what we got? X equal to 1 is local minima. So here we are getting it very easily. Now look at the second one. f2 dash of negative 1. f2 dash of negative 1. 6 into negative 1. It is negative 6. So less than 0. Second derivative less than 0 means what? X equal to negative 1 is local maximum. And we got the same result when we did by the first derivative test. So if second derivative is applied, it is very easy to find the answer. But second derivative test will fail if second derivative is 0. In that case, we have to accept the first derivative test.